is 2/3. All right, that's the final result that we get in this. It says find the exact value, so you should leave it as a fraction. Do not write decimals here. Okay, that's the first question. Let's move on. Question number 2. So the first one was pretty straightforward. As long as you know how to work with infinity, that's all that you've got to do there. Okay. All right. Question number 2. Let's have a look at this. It says the diagram shows part of the curve with the equation y equals k into sine of half x, where k is a positive constant. Now keep that in mind. K is a positive constant, and x is measured in radians. The curve has a minimum point A. This is the minimum point A of the curve. We need to state the coordinates of the point A. Okay, so now what does the function look like? It's k into sine of half x, and there is no way to find the value of k here. So most likely the coordinates have to be in terms of k. Let's think about this. Okay, so the minimum point is A, and it's only a 1 mark question. How can we think about this? Remember what the graph of sine x looks like. So if you have the graph of sine x, how does that look like? It would start from 0, go like this, and this is where it completes one full cycle. If it was sine x function, what would these points be in that case? It would start from 0 on the x-axis, and then when x is pi, it comes back to 0 again, and when x is 2 pi, it comes back to 0 again. And in the middle, this point would be 3 pi over 2, and this point would be pi over 2. That would be for this function sine x. Okay, we're not talking about this function yet. Now what's happening here? Instead of sine x, there are two things happening. So remember, in sine x, we also have this, that on the vertical axis, we've got 1 here, and we've got -1 here. These are the maximum and minimum points of this curve. Now, what is changing in this function? You're multiplying by k outside. What that means is there's a vertical stretch of scale factor k, or you can say the amplitude of this graph would be k in this case instead of 1. All right, so the amplitude in this case is going to be k. If the amplitude is k, what does that tell us about these points where you have the maximum point and the minimum point? The y values are going to be k and minus k. If the amplitude is k, that means the maximum point is going to be k and the minimum point is going to be minus k. So you can think of it both ways. You can think of k as being the amplitude of the sine function, or you could think of k as the scale factor of this vertical stretch. Either way, the y coordinate of this point k turns out to be minus k. All right, so that's what we have figured out here. Now, what about the x coordinate? What is the transformation that is happening horizontally? Half x. What does that mean? You're dividing by 2 inside the function. In horizontal transformation, things work the other way around. So if you're dividing by 2, that means it's a horizontal stretch of scale factor 2. So the period of the graph that was from 0 to 2 pi earlier, what is that going to become now once the graph gets stretched? The period of the graph is going to become 2 pi into 2, that's 4 pi. So this transformed graph, this is going to complete one full cycle only once you have 4 pi here on the horizontal axis. So this point would have to be 4 pi in this transformed function. All right. So after transformation, 2 pi into 2, the point becomes 4 pi. And now what about the x coordinate of A? If this is 0 and this is 4 pi, right in the middle, we would have 2 pi. Then what about this point? This is going to be 3 pi. So the x coordinate of this turning point is going to be 3 pi. So it's 3 pi and minus k. These are the coordinates of the point A. And that's what we were looking for. We had to state these coordinates. So there's a vertical stretch of scale factor k, because of which this is what the y coordinate turns out to be. There's a horizontal stretch of scale factor 2, because of which the point 2 pi goes to 4 pi. And the point that was earlier 3 pi over 2, that becomes 3 pi. after multiplying by 2. So this point is going to be 3 pi. All right, that's the first part. Let's have a look at the next one. Now it says a sequence of transformations, that means more than one transformation, they're applied to the curve in the following order. Now it says translation of 2 units in the negative x direction. So that means vertically, the graph is going to move 2 units down. Reflection in the y-axis, in the x-axis, sorry. Reflection in the x-axis. That means the line of reflection is x-axis. If the line of reflection is x-axis, is that a vertical transformation or horizontal transformation? That's also a vertical transformation, because x-axis being the line of reflection means if there was a point above the x-axis, that goes below the x-axis. If there was a point below the x-axis, that goes above the x-axis. So it's a vertical reflection. So you've got 2 vertical transformations. First of all, there's a translation of 2 units down, and then there's a reflection in the x-axis. Now, how do we think about this? What was the original curve? Y equals k into sine of half x. Right? That was the original curve. Let me write that here. Y equals k into sine of half x. Let's apply these 2 transformations. First of all, you have to translate 2 units in the negative y direction. So to the whole function, from the whole function, you subtract 2, right? Translation means plus minus something. Vertical transformation means you have to do something outside the whole function. So outside the whole function, you subtract 2. That is what happens when you do this translation of 2 units in the negative y direction, 2 units down. Then what you have to do is, after that, you have to reflect in the x-axis. That means it's a vertical reflection, right? I told you why it's vertical. That means something is going to happen to the whole function. Now what we do is, after this first transformation, in the second step, what we can do now is we can say, let's multiply the whole thing by -1. So it becomes k into sine of half x minus 2 whole multiplied by minus. What does that give you? This gives you 2 minus k into sine of half x. This is the equation of the new curve that you get after transformation. Okay, so this is what you have after translation. This is what you've got after reflection in the x-axis. That is one thing that we've got to do. Then it says determine the coordinates of the point on the new curve corresponding to A. Okay, let me answer the questions first. Okay, so first of all, Abdullah, in the previous part, yes, we could differentiate it and put that equal to 0, but notice it's only 1 mark. So you should be able to figure it out without differentiation. But if you want to do that, you can do that. You can get the x coordinate using that as well, and that will work. That should work. Okay, now in the second part, you're saying, don't we put the negative sign only with k? Shouldn't we put the negative sign here? No, it's a vertical transformation. It's a vertical reflection. Vertical reflection means something has to happen to the whole function. So with the whole function, we put a negative sign. So minus has to be multiplied with the whole thing. Okay. What you are saying, so you're saying minus should only be with k. That would happen if it was the other way around. If reflection was happening first, then what you would do would be you would put a minus sign with k sine half x. And then after that, you can do reflection, and that will be -2. But this is different. In this case, the order is different. You first have to do translation. After you're done with translation, this is what you end up getting. Now, this whole thing has to be reflected. So you put negative sign outside. Okay, so that's the equation that you get at the end. All right, now determine the coordinates of the point on the new curve corresponding to A. So what was the point A earlier? The point A we figured out was 3 pi and minus k. 3 pi and minus k. Now, both of these transformations are vertical transformations. So nothing is going to happen to the x coordinate. X coordinate remains the same. It remains 3 pi. 3 pi. What about minus k, the y coordinate? We first have to do a translation of 2 units in the negative y direction. So it first becomes minus k minus 2, right? We subtract 2 from the whole thing. And then it's a reflection in the x-axis. That means the y coordinate gets multiplied with negative. So this is going to become k plus 2. So the final coordinates that you get from this for A are going to be 3 pi and k plus 2. This is where point A is going to be. And this is going to be the equation of the transformed curve. All right. Miriam, you need to be specific. Which part specifically? Which step in particular? The new coordinate? Okay, so if you understand what we are doing here, we're doing exactly the same thing to this point now. There are 2 transformations that are happening. So when you do translation, whatever was the original y coordinate, since you have to go 2 units down, that would become y minus 2, right? And then in the next step, it's a reflection in the y, in the x-axis. That's a vertical reflection. So if it was y earlier, it would become minus y. In this case, it's y minus 2. You get minus into y minus 2. These are exactly the 2 steps that we're applying here. We're saying y coordinate was minus k. So first of all, when we do translation of 2 units down, you say it's going to be minus k minus 2. That's the first thing you do. Because of that translation, you do minus 2 here, just like you were doing minus 2 here. And then because of the reflection, we're multiplying the whole thing by negative. So it basically becomes minus into minus k minus 2, which gives you k plus 2. So in the second step, you're multiplying by this negative sign, just like we were multiplying by the negative sign here. And that gives you the final result. That's the new coordinate. Question number 4. Transformation R denotes a reflection in the x-axis, and the transformation T denotes a translation of 3 minus 1. So we have 2 transformations. One is transformation R. It denotes a reflection in the x-axis, and a transformation T that denotes a translation of 3 and minus 1. Okay, these are two different transformations. Find the equation y equals g of x of the curve with the equation y equals x squared after it has been transformed by the sequence of transformations R followed by T. So first of all, you have to apply transformation R on this, and then you have to apply transformation T. Okay, now how does that work? So what's the equation? The equation is y equals x squared. You first apply the transformation R on this. What's R? R is a reflection in the x-axis. Reflection in x-axis. Is that a horizontal transformation or a vertical transformation? Reflection in x-axis. X-axis is the line of reflection. Any point that's above the line that goes below the line, any point that's below the line that goes above the line, it's a vertical transformation. The y coordinates are changing. So what happens in vertical reflection? You multiply by negative sign outside the function. The whole thing gets multiplied by negative. So the first transformation after transformation R, what happens is this function becomes minus x squared. That's the first thing that happens. Okay, the whole function gets multiplied by negative. Okay, so you get y equals minus x squared. Then you apply transformation T. What's transformation T? Transformation T is translation of 3 minus 1. Now, this is both horizontal and vertical. Horizontally, you're moving 3 units right. Vertically, you're moving 1 unit down. So it's 3 right and 1 down. Now, vertical translation is relatively straightforward. Outside the whole thing, you have to just subtract 1. So basically, after this transformation T, what happens is you have a minus 1 outside. Okay, there's a minus 1 outside. But there's a horizontal transformation as well. And that is 3 units to the right. Now, remember, in horizontal transformations, everything works kind of counterintuitive. If you go right in the function, you do minus. If you go left in the function, you do plus. You're going right here. So instead of x, what are we going to have? We're going to have minus 3, x minus 3, okay? So inside the function, inside the square, so this minus outside remains as it is. Horizontal translation of 3 means instead of x, you are going to have x minus 3. So it becomes minus x minus 3 whole squared minus 1. That is the result that you get from this first transformation. Is that okay? So after reflection, you get this negative sign outside. So this is for that reflection. And with translations, you get this minus 3 inside and you get a minus 1 outside. Okay, that's the final result that you get. All right, let's move on. Find the equation y equals h of x of the curve with the equation y equals x squared after it has been transformed by the sequence of transformations t followed by r. So now we have t applying first and then r. Okay, so let's think about this now. Y equals x squared. Now t happens first. What's t? T is translation. So you have to translate the graph first. So what you do is, in place of x, you do x minus 3. So it becomes x minus 3 whole squared. All right. Due to the horizontal translation. Due to vertical translation, you have a minus 1 outside. So x minus 3 whole squared minus 1. After the translation is applied, you get x minus 3 whole squared minus 1. 3 subtracted inside because you're going right. In horizontal transformation, that means minus something. You're going down by 1 unit, that means minus 1 outside. Okay, that's what we get. Then what happens is, you have the second transformation happening, that's r. R is reflection in x-axis. That's a vertical transformation because reflection in x-axis means any point that was above the x-axis that goes below the x-axis, any point that was below the x-axis that goes above the x-axis. So it's a vertical reflection. So now the whole thing, the whole function gets multiplied by negative. So what do we get from that? Y equals minus into this whole thing. Minus into x minus 3 whole squared minus 1. And now if you wanted to simplify this, it would become minus into x minus 3 whole squared plus 1. This is the transformed function that you get. Okay. Now they're saying the first function is the first function is g of x. So they're saying this is g of x. And they've also told that this is h of x, right? This is the result that we get from that. So we have a function g of x and we have a function h of x. Now they say state fully the transformation that maps the curve g of x onto the curve h of x. Now remember, whenever in quadratic functions, you have to find out transformations yourself and you have to figure out what transformations are happening. You need the function to be in completed square form. Now, in this case, it's already in completed square form, so you don't need to do anything else with this. You have to go from g of x to h of x, right? And that's what happens. Okay, now, what's g of x? That's minus into x minus 3 whole squared minus 1. That goes to minus into x minus 3 whole squared plus 1. How do you go from this first function to the second function? What transformation is happening? And that's what we need to figure out. Now think about this. This part is not changing at all. Minus x minus 3 whole squared minus x minus 3 whole squared. That means there's nothing happening inside the function. So inside the bracket, inside the square, for example, you see you've got x minus 3, you've got x minus 3 here. There's nothing happening horizontally. There's no horizontal transformation that's happening here. What's happening outside the function? We have minus multiplying outside. Here we have minus multiplying outside. It's just the number outside that has changed. This was minus 1 earlier, now it becomes plus 1. How do you go from minus 1 to plus 1? Do you multiply by negative sign? No, because if it was multiplication with negative sign, then this would also have changed. This would also have become positive sign. So if it was positive, then you could say it might have multiplied by minus 1, but this is not multiplication because the sign outside, that's not changing. So the function is not being multiplied by negative 1. What else could happen? -1 is going to +1, you could say you're adding 2 to this whole thing. If you add 2 outside this function, that will give you this result. So add 2 to the whole function. When you add 2 to the whole function, what kind of transformation is that? It's a vertical translation. The graph moves 2 units upwards. How would you describe this translation? This transformation, you would say it's a translation. Remember, in translation, it's necessary for you to write down the vector. If you're doing past papers, old past papers as well, until a couple of years back, they used to allow you to write down that the graph is going 2 units down. They do not allow that, 2 units up, sorry, in this case. They do not allow that anymore. You have to write down the vector. Writing down the vector is important, and that's necessary. So what's the translation vector then? That's 0, 2. There's no horizontal translation. There's a vertical translation. You're adding 2 to go to the other, to go to this thing. So you have +2 here. Okay, so there's a vertical transformation, 2 units upwards. You would say it's a translation. Using the word translation is important, and writing down the vector is important. The vector is 0, 2. Okay, all right. So the first really difficult looking question is question number 8, and that's what most of you are actually asking. Let's start with this one, and then we'll have a look at some others. Okay, question number 8. It says the diagram shows part of the graph of y equals sine of a into x plus b, where a and b are positive constants. State the value of a and one possible value of b. Okay, so you have a sine function, and you have the graph given here. We need to state the value of a and one possible value of b. Now, the function is written in a form like this: sine of a into x plus b. What's the standard sine function? It's sine x. So the sine x function is basically transformed to this function. Now, for this, it's really important that you understand the order of transformations very well. Now, many people actually struggle with that. So I'll quickly just show this to you. And I would recommend that you go through this if you do not know about this already. Functions, order of transformations. So you need to remember this. Whenever you have multiple transformations happening in the same function, this is how you basically figure out which transformation to do first and which transformation to do next. If you have some horizontal and some vertical transformations, it doesn't matter which one of them you do first. You could start with horizontal first, you could start with vertical first. So when you have horizontal and vertical combined, between horizontal and vertical, it doesn't matter. You could do horizontal first or vertical first. Any of them would work. Why? Because horizontal transformations only change x coordinates and vertical transformations only change y coordinates. You could do any of them first. However, if you have multiple vertical transformations, and it's a form like this, you do stretch or reflection first. So this -2, that is going to be applied first. And then this +3, because of its translation is happening, that happens next. If it's in standard form like this, okay? Sometimes they use some extra bracket somewhere. In that case, the order ends up reversing. But if it's a standard form like this, -2 into f of x plus 3, stretch reflection happens first and translation happens next in vertical transformations. In multiple horizontal transformations, when you have something standard like this, something in standard form like this, then you have f of some number into x and then plus minus something. In horizontal transformations, it works the other way around. Just like everything else works the other way around in horizontal transformations. Right means negative means right, positive means left. And in stretch, when you multiply by something, the scale factor is reciprocal of that, right? In horizontal, everything works the other way around. The order also works the other way around. If it's a standard form, if it's in standard form like this, f of some number into x plus minus something, translation is applied first, stretch and reflection are applied afterwards. You need to remember this order whenever you have something in standard form like this. Now, sometimes they confuse you. They confuse you like this, that they do not use the standard form. Instead of this, they would put some brackets, some extra brackets. They might write something like this, minus 2 into f of x plus 3. So they might write something like this. Now, this is also vertical transformation because you're not changing anything to x. You're basically doing something outside the function. Both of these transformations are vertical transformations, okay? However, these brackets basically force the order to be different. Because of these brackets, now translation would be applied first and stretch would be applied second. So when they use extra brackets like this, the order changes because of that. But if it's in standard form, this is the order that applies. First stretch reflection, then translation for vertical transformations. And for horizontal transformations, it's first translation and then stretch reflection. In horizontal as well, again, they'll mess things up a little sometimes. They will write something like this, just like in this question that we're doing. They have used extra brackets. So they have something like this. So instead of minus 5x plus 2, if they had something like this, f of minus 5 into x plus 2. If they did it like this, what happens now? The standard order in horizontal was translation first and then stretch reflection. But when they make it like this, it reverses. You first have to do stretch in this case, in horizontal transformations, and then you do translation when they use extra brackets like this. Okay, I hope that makes sense. Now, one idea is that whenever you have something, you convert it to standard form first and then think of transformations. That's one idea, okay? Convert everything to standard form first and then just remember the standard order. Just use the standard order by converting everything to standard form first of all. Let's do it this way first. Let's go back to that question now. This was question number 8 from this paper. You see, they've used extra brackets here like this. Now, you could first convert it to standard form. How would you do that? You could write this function as sine of ax plus ab. You could write it like this. And now it's the standard form. What are you going to do first? This is horizontal transformation. You first do translation and then you do stretch in this particular form. Okay, just keep that in mind. Now that we understand the order, let's see how we're actually going to use this here. Remember what the original function is, sine x. This function is going to sine of a into x plus b. Is it something happening inside the function or outside the function? Something is happening inside the function. X is changing. X is going to some other value. So this is horizontal transformation, right? If it was vertical transformation, something would change outside the function. Something is changing inside the function here. So the only transformation that's happening is horizontal. That's one thing. The transformation is horizontal. Now, if the transformation is horizontal, let's think about what has changed horizontally. Remember the standard sine graph. It starts from 0 at 𝗨/2. So let me write it in master part here. It goes like this. At 𝗨/2, it goes to 1. At pi, it becomes 0. And then it goes negative here, and then it completes the cycle at 2 pi. That's the standard sine graph. Now think about it. The original period was 2 pi. The original period of the sine graph. The original period is 2 pi. What about the period of this graph that they have given us? What's the period of this graph? For sine x, it was 2 pi. What about this graph? This is 1/2 of the graph. This is 1/2 of the graph. How much is this? Minus pi over 3 to 5 pi over 3. What's that distance? You can do it on a calculator. 5 pi over 3 minus pi over 3. That's basically 2 pi. So 5 pi over 3 plus pi over 3. That gives you 2 pi. That's 1/2 of this graph. What will be the complete period when it completes one cycle? The complete period would be 4 pi. So can you think of what transformation is happening here? 2 pi is going to 4 pi. It's a horizontal stretch. What's the scale factor? The scale factor is 2. Horizontally, the graph has stretched by a factor of 2. So the original period that was 2 pi, now it is 4 pi. Okay. Now, what does that mean? If the scale factor is 2, in horizontal transformations, remember what happens? If the original function was f of x, where does that go? That goes to half x. When scale factor is 2, you basically divide by 2. So now think about this. It's a times x. For the stretch to happen, what is x going to be multiplied with? What is x going to be multiplied with? 1 over 2. So the value of a, therefore, is supposed to be 1 over 2. Why? Because the scale factor is 2. In horizontal transformation, the scale factor is reciprocal of the number that you have multiplying inside. The reciprocal of 2 is 1 over 2. So the value of a is supposed to be 1 over 2. So now we know that it looks like this. Sine of 1 over 2x plus 1 over 2 times b. Does that make sense? The value of a has to be 2. Now the problem is, how do you find the value of b? How do you find the value of this b now? Now that's slightly more complicated. Let's think about it. So again, we could think of it both ways. So remember the standard order that we have. The standard order that we have. If it's in this form, what happens first and what happens second? If it's in this form, first of all, you have translation. Then you do stretch. What they've done here is, in this form, if you were to keep it in this form, you would say, in this form, since they have put extra brackets there, this order would be reversed. So in this case, you would first have stretch and then translation. Okay. So depending on which form you're using, let's use this one, the one that they've given, and then I'll explain to you using the other form as well. Let's use actually this one first. I think this is going to make it easier in this particular case. In this case, you would say first you do stretch because you've already figured out the stretch. You can represent that here. What was the original graph like? This was the original graph. When you stretch it by a factor of 2, where does that go? After the stretch happens, this graph becomes this. It goes to pi, and then it goes to 2 pi. So after stretching the graph, this is what the result turns out to be. And then you have to go from this orange graph to this black graph. How do you go from the orange graph to this black graph? What translation is happening after that? How many units is the graph moving left or right in order to go from orange to black? It's going some units to the left. It's easier to look at it from here. 0 is going to minus pi over 3. It's going pi over 3 units to the left. If we do stretch first and translation second, it's going pi over 2 units to the left. sorry, pi over 3 units to the left. This is pi over 3. It's going pi over 3 units to the left. So the translation that we have is pi over 3 units to the left. Now, it's not necessary to describe this transformation. Just understand this. It's going pi over 3 units to the left. If it's going pi over 3 left, what happens here? What's the value of b going to be? You have to go how many units to the left? Pi over 3. Left means plus in horizontal transformations. So this is going to be, this number b is therefore going to be pi over 3. You would say the value of b turns out to be pi over 3. That's one way of thinking about this, that you think of stretch first. Since stretch is easy to figure out in most cases because stretch changes the size of the diagram, it's easy to figure out that the stretch is by a scale factor of 2. So once stretch happens, after that, how many units do you have to go to the left? That's pi over 3 units in this case. Now, if you were to do it using the standard form, how would you think of it in that case? That's a bit more complicated in this case. I'll just quickly explain that. And let's see if that makes sense to you. We already came to this point, right? Stretch factor is going to be the same scale, that's scale factor 2. So this is 1 over 2. Figuring out a is going to be the same process as before. However, if we were doing translation first and then doing stretch, think about this. This original graph, it looks like this. This point origin has to go to minus pi over 3. We have to make this point go to minus pi over 3. If we do translation first and stretch second, we already know that the scale factor of the stretch is going to be 2. So wherever the origin goes, after reaching there, it has to be multiplied by 2. So if we do translation first, when we do translation first, we would have to take it to this point here. So that when we multiply it by 2 later on for doing stretch, it goes to minus pi over 3. So if you were to use this form where we do translation first, you would have to go from origin to this point here. And then you multiply that by 2 to reach this final result. Now, what's this midpoint? The point between pi over 3 and 0. This is going to be minus pi over 6. This is minus pi over 6. That means it's pi over 6 to the left. So this number here, that's encircled here, this number should have been pi over 6. So 1 over 2 into b equals pi over 6. That also gives you b equal to pi over 3. But that, I think, in this particular case makes it slightly more complicated. That's why they've given it in this form. So you need to remember, if they use an extra bracket here like this, they're forcing the plus to be first and the multiplication to be second. It's going to reverse the standard order that you have in horizontal transformations. If you were to use this form as it is, standard order for horizontal transformations was that you do translation first and then do stretch reflection. But since in this case, they've forced the order to be different using these brackets, that order reverses. You do stretch first and translation second. And that's how we figured it out the first time, in the first method that we did. I hope I've not confused you with both methods, but I hope that makes sense now. Order of transformations is very important to understand. In recent papers, you will find that you'll find every other question on transformations that requires, it would require the order to be correct. If you just do it randomly, in most cases, you would end up getting wrong results. So you have to make sure, you have to be very conscious of what transformation to do first, what transformation to do second. So you need to remember these orders that I just showed you in the standard form. These are the orders that you have. If they force something else using brackets, that order reverses in that case. But you have to remember the standard order, and then depending on what they've given, you should be able to figure out if the order is going to change in that case or not. Okay, now this was quite complicated, and that's okay. That does happen sometimes. Yeah, part B is also, I think, a bit more complicated. We'll have a look at that. Before that, let me know if you have any questions on this. Any problems, anyone? Okay, good. All right, let's move on to the next one now. Now, part B now. In fact, just give me a second. I'll just connect my charger. Otherwise, it's going to turn off. That will take too much time then. Just give. All right, let's have a look at part B now. So what does part B say? It says another curve with equation y equals f of x has a single stationary point at the point PQ. Okay, so now this is a different curve. It does not really, yeah, it's not related to the first part. Another curve with equation y equals f of x, it has a single stationary point at the point PQ. So this is the point that we have, PQ. Where P and Q are constants, the curve is transformed to a curve with this equation. So f of x goes to this. And now they're asking, for the transformed curve, find the coordinates of the stationary point, giving an answer in terms of P and Q. So for the transformed curve, we need to find the stationary point. Now, how is the curve changing? It's going from f of x to 3, in fact, minus 3, f of 1 over 4 into x plus 8. You see, they've done something very similar here as well. They've introduced an extra bracket here. And what that does is that reverses the order of transformation. Okay, now let me explain what that means. So what transformations do we have first of all? We've got minus 3. What does minus 3 mean? This is the first transformation, right? It's a vertical transformation. It's a vertical stretch. There's no other vertical transformation. So we could just say, number 1, the first transformation that's happening is, it's a vertical stretch with scale factor minus 3. Or you could break it down into 2 parts as well. You could say it's a stretch with scale factor 3 and a reflection in x-axis, right? But you could write it as a single transformation as well. You could say it's a stretch with scale factor -3. Now, writing this description is not important. It's just for your own understanding that this is the first transformation that's happening. Now, what happens when this transformation is applied? Where does PQ go? It's a vertical transformation. It does not affect the x coordinate. X coordinate P remains as it is. What happens to the y coordinate? Q. Where does Q go? Scale factor is -3. q gets multiplied by -3. So it becomes -3 times q, right? So wherever it was before, it just gets multiplied by -3. The y coordinate gets multiplied by the scale factor because it's a vertical stretch. That's what happens with this vertical transformation. Okay, then we have horizontal transformations. We have two horizontal transformations. There's a stretch because there's a multiplication. There is a translation because there's a plus there as well. Now, which one of them do we do first? Again, what they've done is they've introduced these extra brackets here. What's the standard order in horizontal transformations? The standard order, if it was written like this, if it was written without any brackets, if it was 1/4x plus 8/4, that's 2. If it was written like this, we would do translation first and then do stretch. In introducing this extra bracket, they are forcing us to do stretch first and then translation. So it reverses the order. So if you were to use it as it is, you would say first do stretch here. Generally, we do translation first in horizontal, but using these brackets, they've forced us to do it the other way around. You do horizontal stretch with scale factor. What's the scale factor? It's multiplying by 1/4. What about the scale factor? It's reciprocal of that. The scale factor is going to be 4 in this case. Okay. So what happens in this case? So this was what we had gotten to already. After the second transformation, where does this go? So we had p and -3q. It becomes 4p and -3q. The x coordinate gets multiplied by 4. Okay. And then we do the third transformation. That's +8 here. So this was 1/4, the horizontal stretch. And then we have this +8. That's a translation. +8 means it's going toward the left. So it's translation -80. It's going to the left. But writing down the vector is not important here because we just need to write down the final coordinates. What happens in this case? We're going 8 units to the left. So what do you get? You had already gotten to this point, 4p -3q. Where do you go next? In the x coordinate, since you're going 8 units left, you would say this is 4p -8 and -3q. This is the final result that you get from this. 4p -8 and -3q. That is where this turning point goes at the end. Okay. This is one way of thinking about this. Again, you could do it in standard order as well. If you wanted to write it in standard form first, you would do the standard order in that case. You could write it like this first, removing the bracket, -3 into f of 1/4x plus 2. This is what it would become in that case. Now what would happen would be, actually, let me just do it quickly without writing down too many explanations here now. -3, what happens because of that? Because of -3, it becomes p and 3q, -3q, sorry. That's the first transformation that happens. Okay. Then, now it's standard form. In standard form, you do translation first. So now you would do translation first. What color had I used there? Now you do translation first. And now after the second transformation, where does this point go? You're doing translation first now. +2 means you're going 2 units left. That means p -2 -3q. And then you do stretch 1/4 by a factor of 1/4. Where does this go now? After that stretch is applied, you multiply p -2 by the scale factor. Remember what the scale factor is? It's 1/4. Scale factor is reciprocal of that. That's 4. So it becomes 4 times p minus 2 and minus 3q. And that also simplifies to 4p minus 8 and minus 3q. That could be another way of doing this, by converting it to standard form first, and then applying translation first, and then applying stretch. Okay, so you need to be very clear in your head how this order works. Okay, in the standard form, in horizontal, it's translation first, then stretch reflection. If they introduce brackets like this, then that order reverses. Is that okay? This was a very tricky question. So go through this again in your own time to understand this well, because this does make the order of transformations thing very clear if you understand this well. Okay, so that was question number 8. Now let me just have a look at the next one. What was the next one? Let's do one more. I think one other question has a large number of votes, I think. Let's move on. Let's look at the next one. We have this function f, which is defined by f of x equals x squared minus 2x plus 5 for all real values of x. Okay. We have this function x squared minus 2x plus 5. A sequence of transformations is applied in the following order to the graph of y equals f of x to give the graph of y equals g of x. f of x पे आपने एक कुछ transformations apply की हैं और उससे आपने g of x बना दिया है. What you have to do is you have to find g of x, giving your answer in the form ax squared plus bx plus c, where a, b, and c are constants. Okay. Now, how do we think about this? We have 3 transformations. One is stretch parallel to x-axis with scale factor 1/2. So that's horizontal stretch. The next one is reflection in the y-axis. Then you have stretch parallel to y-axis with scale factor 3. Now, it's often easier to do if you convert it to the completed square form, first of all. उससे थोड़ा सा आसान हो जाता है सोचना, लेकिन वो तब होता है जब आपने खुद से ट्रांसफॉर्मेशंस फिगर आउट करनी हो. खुद से फिगर आउट करना पॉसिबल नहीं होता जनरली जब तक आप स्क्वायर कंप्लीट नहीं करें क्वाड्रेटिक फंक्शंस का. यहाँ पे तो ट्रांसफॉर्मेशन से दी हुई हैं, वो आपने अप्लाई करनी है. सिर्फ आप चाहें तो इनको डायरेक्टली भी कर सकते हैं, इसी फॉर्म में भी कर सकते हैं. दैट इज गोइंग टू वर्क. स्क्वायर कंप्लीट करके करना चाहें उस तरह भी कर सकते हैं, इस तरह डायरेक्टली भी कर सकते हैं. Okay, so what exactly do we have to do here? We have f of x equal to x squared minus 2x plus 5, and x could be any real value here. It says a sequence of transformations is applied in the following order to the graph of y equals f of x to the graph of y equals g of x. Now, the first thing that's happening is, so let's say the original function is f of x. Let's do it this way. The first thing that's happening is you have stretch parallel to the x-axis. That means this is horizontal stretch. So function के अंदर कोई change हो रहा होगा. Stretch से multiply करते हैं. Function के अंदर आप multiply करोगे किस चीज के साथ? First step में horizontal stretch में आप function के अंदर क्या करोगे? 1/2 scale factor है, आप 2 से multiply कर दोगे अंदर. That's the first thing done. So after the first transformation, this is what happens. Then the second thing that happens is reflection in the y-axis. What does that mean? Reflection in y-axis. So if you have a graph like this, if you have something on the right side, it'll go to the left side. ये इस तरह से आपकी रिफ्लेक्शन होके दूसरी साइड पे चला जाएगा, राइट? तो मूवमेंट किस तरह से है? ये हॉरिजॉन्टल मूवमेंट है. वाई एक्सिस में जो रिफ्लेक्शन होती है वो हॉरिजॉन्टल रिफ्लेक्शन होती है. सो दिस सेकंड ट्रांसफॉर्मेशन इज एक्चुअली हॉरिजॉन्टल रिफ्लेक्शन. हॉरिजॉन्टल रिफ्लेक्शन का क्या मतलब है? एक्स की जगह पे -x आ जाता है, फंक्शन के अंदर माइनस लगा देते हैं. तो सेकेंड ट्रांसफॉर्मेशन के बाद क्या होगा, अंदर आपके पास माइनस भी लग जाएगा, so you have f of minus 2x. That's what happens after the second transformation. And then you have the third transformation, which is stretch parallel to the y-axis. This is vertical stretch now. This is vertical stretch. Vertical stretch में आप क्या करते हो, फंक्शन के बाहर मल्टीप्लाई करते हो. किससे मल्टीप्लाई करना है, 3 से मल्टीप्लाई करना है. So you have 3 into f of minus 2x. Okay, this is what the final result should turn out to be after the third transformation. So आपको ये चाहिए at the end, जो आपका function g of x होएगा, that's going to be 3 into f of minus 2x. उसमें क्या करना है, आपने ये changes करनी है, ये हम करते हैं. So 3 into f of minus 2x, x की जगह पे minus 2x डाल दें वहां पे उस function के अंदर, 3 बाहर multiply हो रहा है पूरे के साथ. So you have minus 2x whole squared minus 2 into minus 2x plus 5, and then you simplify this. This gives you minus 2x whole square, that's 4x square, plus 4x plus 5, and this gives us 12x square plus 12x plus 3 into 5, which is 15. So that's the final result that we get from this. This is what g of x turns out to be. Okay, so that's what we were looking for in the second question. आपको ये तीनों ट्रांसफॉर्मेशंस अप्लाई करनी थी. इस केस के अंदर हम इसको डायरेक्टली कर सकते थे without having to convert it to the completed square form, because इसमें आपको ट्रांसफॉर्मेशंस पता थी. जब ट्रांसफॉर्मेशंस पता होती हैं और आपको बस उनको अप्लाई करना होता है तो आप डायरेक्टली कर सकते हैं. अगर आपको ट्रांसफॉर्मेशंस फिगर आउट करनी है तो उसमें फिर आपको पहले का स्क्वायर कंप्लीट करना पड़ता है, अदरवाइज वो समझ नहीं आता. सो फॉर एग्जांपल, अगर आपको ये दिया होता है x स्क्वायर माइनस 2x प्लस 5 है और वो ये बन गया, इट्स वेरी डिफिकल्ट टू स्पॉट कि ये कौन सी ट्रांसफॉर्मेशंस हो रही हैं, अनलेस आप इसको इन दोनों को पहले कंप्लीटेड स्क्वायर फॉर्म में रखो और फिर आपको समझ आएगी कि अच्छा ये ट्रांसफॉर्मेशन हो रही है. लेकिन यहाँ पे ट्रांसफॉर्मेशंस पता थी, यहाँ पे बस उनको अप्लाई करना था, इनको डायरेक्टली भी कर सकते हैं इस केस के अंदर. Let's move on to the next one. Question number 9. Functions f and g are both defined for x for all real numbers. We have to first express f of x in this form and express g of x in this form. This और फिर g of x को इस फॉर्म में करना है. ट्रांसफॉर्मेशन आ रहा है, वरना शुरू में तो आसान लगे. चलिए लेट्स डू दिस. फर्स्ट पार्ट में आपने स्क्वायर कंप्लीट करना है. व्हाट यू कैन डू इज यू कैन से x स्क्वायर का कोएफिशिएंट ऑलरेडी 1 है, so you don't have to do anything with that. x squared minus 4x, you add 2 squared and you also subtract 2 squared. You have plus 9 outside. These three terms give us a perfect square, and we get x minus 2 whole squared minus 4 plus 9, and the completed square form turns out to be x minus 2 whole squared plus 5. That is what f of x is in completed square form. Okay, now we have to express g of x in this form as well. Now how do you convert something to this form? आपने उसी तरह से स्क्वायर कंप्लीट करना है इसमें भी. सबसे पहले आपने स्टैंडर्ड मेथड अप्लाई करना है और फिर आपने देखना है कि इस फॉर्म में कैसे कर सकते हैं. और अनदर आइडिया इज, इसने यहाँ पे क्या किया हुआ है, 2 को कॉमन लिया हुआ है पूरे फंक्शन के साथ, तो आप यही कर लें, 2 को कॉमन ले लें पूरे फंक्शन में से. सो g of x is equal to 2x squared plus 4x plus 12. What they've done is, this is not the standard completed square form. इसमें 2 पूरे में से common लिया हुआ है, so that's what you can do. You can say let's take 2 common from the whole thing. What are we left with inside? x squared plus 2x plus 6. 2x के बाद थोड़ी space छोड़ दें. Then you can say let's add 1 squared here and subtract 1 square. यहाँ से आपका square complete हो जाएगा, and that gives you 2 into x plus 1 whole squared minus 1 plus 6, which is 5, and that's what we were looking for. ये आपके पास ये फॉर्म आ गया. इसको सिंप्लीफाई नहीं करेंगे, 2 उसने बाहर पूरे में से कॉमन लिया हुआ है, वो वैसे ही रहेगा. ठीक है, अच्छा. Let's move on to the next part. Now it says express g of x in this form where k and h are integers. g of x को आपने f की terms में लिखना है कुछ. How do you do this? You have to think of some transformation of f of x that would convert it to g of x. f of x में कौन सी ट्रांसफॉर्मेशन करेंगे आप तो वो g of x में कन्वर्ट हो जाएगा. Now remember उसने यहाँ से फर्स्ट टू पार्ट्स में ना आपसे ये स्क्वायर कंप्लीट करवाया है खुद से. अगर वो ना भी करवाता तो आपको खुद से करना पड़ता है, वरना आपको समझ नहीं आती कि कौन सी ट्रांसफॉर्मेशन हो रही है. सो उसने आपको एक तरह से हिंट दिया है कि आपको ये कंप्लीटेड स्क्वायर फॉर्म यूज करनी है. ठीक है, so you have to somehow figure out a way to convert f of x to g of x, right? फिर आप उसको g of x के इक्वल कर सकते हो, right? तो f of x में हम क्या चेंज करेंगे तो वो g of x बन जाएगा. That's what we need to think about. Now what is f of x? f of x is x minus 2 whole squared plus 5, right? And what about g of x? G of x is 2 into x minus 2 whole squared. No, sorry, what am I writing? 2 into x plus 1 whole squared plus 5. Okay, this is what the functions are. अब देखें उसने ना आपको ये भी अब एग्जैक्टली बता दी कि कौन सी ट्रांसफॉर्मेशन हो रही है एक तरह से, बिकॉज बाहर उसने के लगा दिया है, इसका मतलब है एक वर्टिकल स्ट्रेच है, और अंदर उसने क्या किया है, उसने x प्लस एच कर दिया, यानी कि एक ट्रांसलेशन है. सो उसने थोड़ा सा आसान कर दिया आपके लिए एक तरह से. तो अब आप देखें कि f ऑफ x अगर ये है तो इसमें क्या चेंज आप करेंगे तो वो ये बन जाएगा. आपको फंक्शन के बाहर पूरे फंक्शन के बाहर क्या करना है, 2 से मल्टीप्लाई करना है. So what that means is you are going to have 2 into f of x. ठीक है, ये आपने सिर्फ अभी क्या किया, सिर्फ स्ट्रेच 2 से मल्टीप्लाई करने से ये हो जाएगा. एक तो ये चीज हो गई. फिर अब आपने सोचना है कि अंदर क्या होगा फंक्शन के. x माइनस 2 था ये पहले, x माइनस 2 को आपने x प्लस 1 बनाना है. तो आप कैसे -2 से +1 पे जा सकते हैं, आपको क्या करना पड़ेगा, फंक्शन के अंदर 3 ऐड करना पड़ेगा, राइट? x माइनस 2 में आप 3 ऐड करेंगे तो आपको वो मिलेगा. तो आप क्या करोगे, यहाँ पे x के साथ फिर कहोगे this should be x plus 3 like this, and this is what it's going to look like. All right, so you could say g of x is therefore 2 into f of x plus 3. All right, okay, let's move on. Now it says describe fully the two transformations that have been combined to transform the graph of f of x to the graph of g of x. ये कौन सी दो transformations हो रही हैं? You have to describe those transformations. Now once you've converted it to this form, this is pretty straightforward. अगर आपको transformations के concepts ठीक है तो this is pretty straightforward. इसमें order भी matter नहीं करता because one is vertical and the other is horizontal. तो order जो मर्जी हो सकता है, right? Because इनका आपस में order नहीं matter करता. तो आप जो मर्जी पहले लिख सकते हैं. तो कौन सी transformations हो रही है? You can say there's a vertical stretch, or you can say there's stretch along y-axis. There is stretch along y-axis with stretch factor what? 2. Okay, by 2 से multiply हो रहा है तो scale factor, stretch factor इसमें क्या होगा? 2 होगा. That's one thing that is happening. What about the horizontal transformation? The horizontal transformation is a translation. +3 करने से क्या होता है, आपका ग्राफ 3 यूनिट्स लेफ्ट मूव करता है. जब इक्वेशन के अंदर x की जगह पे आपके पास कुछ x के साथ कुछ प्लस हो रहा हो तो आप लेफ्ट पे जाते हो, माइनस हो तो राइट पे जाते हैं. रिमेंबर हॉरिजॉन्टल ट्रांसफॉर्मेशंस में उल्टा चल रहा होता है सब कुछ, राइट? सो ये ट्रांसलेशन कौन सी है? दिस वाज द फर्स्ट ट्रांसफॉर्मेशन. ट्रांसलेशन क्या लिखेंगे? रिमेंबर ट्रांसलेशन में यू कांट डिस्क्राइब इट इन वर्ड्स. आपको ये वर्ड लिखना है ट्रांसलेशन एज इट इज, एंड यू आल्सो हैव टू राइट डाउन द कॉलम वेक्टर फॉर दैट ट्रांसलेशन. क्या होगा ये? +3 का मतलब है 3 यूनिट्स लेफ्ट, तो आपको यहाँ पे लिखना पड़ेगा -30. ओके, ट्रांसलेशन वेक्टर में -3 लिखेंगे because -3 here in the vector would mean that you are going 3 units to the left. Okay, let's move on. Question number 5. Now this is the diagram shows a curve which has a maximum point at 812 and a minimum point at 80. The curve is the result of applying a combination of two transformations to a circle. The first transformation applied is a translation of 7 minus 3. The second transformation applied is a stretch in the y direction. State the scale factor of the stretch. Okay, आपको डायग्राम नजर आ रही है और ये रिजल्ट है दो ट्रांसफॉर्मेशंस अप्लाई करने का. So this is the final result that you're getting after that. वो कौन सी दो ट्रांसफॉर्मेशंस हैं? The first transformation is a translation of 7 minus 3. And the second transformation is a stretch in the y direction. Stretch in the y direction, right? So we need to first of all state the scale factor of the stretch. Now, how does that work? देखें, translation से तो आपकी figure का size नहीं change होता, वो same ही रहती है. ठीक है, तो translation तो size में कोई फर्क नहीं पड़ा होगा. लेकिन जो दूसरी transformation है वो क्या है? There's a stretch in the y direction, vertical stretch है. तो vertically आपका जो उसका है ग्राफ जो है वो स्ट्रेच हो गया हुआ है इस पार्ट के स्ट्रेच की वजह से, राइट? तो वर्टिकली मूवमेंट हुई है. तो अब वो कितना स्ट्रेच हुआ होगा? आप सोचें, ये सर्कल था इनिशियली, हॉरिजॉन्टली तो कोई चेंज नहीं आई है. हॉरिजॉन्टली कोई चेंज नहीं आई है, तो इसका मतलब है जो सेंटर अगर हम यहाँ पे होता, लेट्स अज्यूम, तो रेडियस कितना होना चाहिए था इसका? 2 यूनिट्स, राइट? तो फिर सर्कल बनाने के लिए जो इसका वर्टिकल होगा वो भी 2 यूनिट्स ही होना चाहिए था. तो ये आपका इस तरह से कुछ सर्कल हो सकता था, राइट? अब क्या हुआ है? ये वर्टिकली 2 यूनिट्स के बजाय कितना हो गया? 6 यूनिट्स हो गया स्ट्रेच. ठीक है, तो 2 से आप 6 यूनिट्स पे चले गए हो. व्हाट इज द स्केल फैक्टर? 2 को किससे मल्टीप्लाई करेंगे तो 6 आएगा? 3. द स्केल फैक्टर दैट यू हैव इज 3. सो एसेंशियली वर्टिकली आपने y कोऑर्डिनेट्स को 3 से मल्टीप्लाई कर दिया. दैट्स व्हाट हैज हैपेंड. अच्छा, now let's look at the second part. It says state the radius of the original circle. Now we already figured that out. Radius क्या होना चाहिए था original circle का? 2 units, right? So let's write that here. Radius should have been 2 units. Part C. It says state the coordinates of the center of the circle after the translation has been completed, but before the stretch is applied. अच्छा, so stretch को आपने reverse करना है. Stretch को reverse करना है. ओके, अब ये कौन सी स्ट्रेच है? वर्टिकल स्ट्रेच है. वर्टिकली ग्राफ मूव हो रहा है. ओके, वर्टिकली ग्राफ मूव हो रहा है. अब देखें, वर्टिकल ग्राफ जब मूव होता है, आपका जो रेफरेंस लाइन होती है, इनवेरिएंट लाइन, वो आपकी एक्स एक्सिस होती है. एक्स एक्सिस से आप देखते हो डिस्टेंस कितना हो गया. नाउ लुक एट दिस पॉइंट जो 12 पे चला गया है. स्केल फैक्टर आपका क्या था? 3 यूनिट्स. तो 12 पहले क्या था जो 3 से मल्टीप्लाई होकर 12 पे चला गया है? आप 12 को 3 से डिवाइड करोगे, ये वाला पॉइंट कहाँ पे होना चाहिए था? ये पॉइंट इधर होना चाहिए था 4 के ऊपर, राइट? बिकॉज पहले इसका डिस्टेंस 4 यूनिट्स होता फिर, और फिर स्ट्रेच होके कहाँ चला जाता? 12 पे चला जाता. तो इसका जो स्केल फैक्टर है 3 है उस वजह से. तो 12 वाला पॉइंट जो ऊपर मैक्सिमम पॉइंट है वो किधर होना चाहिए था? वो 8 4 पे होना चाहिए था, राइट? तो मैक्सिमम पॉइंट ऑफ सर्कल का यहाँ पे होना चाहिए था, इस पॉइंट के ऊपर. That means your circle would have looked something like this originally. Stretch से पहले आपका सर्कल कुछ इस तरह से होना चाहिए था. All right, what's the center of that circle? This is the center of the circle, which has coordinates 8 and 2. So that's what you write here. We say the coordinates of the center of the circle are 8 and 2 like this. ठीक है, तो आपने y एक्सिस के पर्सपेक्टिव से देखना है, x एक्सिस के पर्सपेक्टिव से देखना है, हॉरिजॉन्टल लाइन के पर्सपेक्टिव से. पहले कितना डिस्टेंस था उसको 3 से डिवाइड कर दिया. ठीक है, नाउ इट सेज स्टेट द कोऑर्डिनेट्स ऑफ द सेंटर ऑफ द ओरिजिनल सर्कल. तो आपने ट्रांसलेशन को रिवर्स करना है. ट्रांसलेशन में क्या हुआ था? 7 यूनिट्स राइट गए थे, राइट, और 3 यूनिट्स लेफ्ट गए थे. आपने उसका उल्टा करना है, वापस जाना है ना अपने ओरिजिनल सर्कल के ऊपर. तो हाउ डू यू गो बैक नाउ? उसने सेंटर का पूछा, सेंटर पहले कहाँ पे था? अब तो A2 पे आ गया है. अगर हम उसके कोऑर्डिनेट्स को ऐसे लिखते हैं A2, तो अब हमें क्या करना है? या उसी तरह लिख देते हैं, just to make sure it does not get confusing. A2 आपके कोऑर्डिनेट्स हैं. ट्रांसलेशन क्या हुई थी? 7 यूनिट्स राइट पे चले गए थे, हमने उसको रिवर्स करना है. तो हम क्या कहेंगे? x कोऑर्डिनेट में से 8 आप माइनस कर देंगे, वापस जाना ना, उसमें से माइनस कर देंगे 8। और ट्रांसलेशन में वर्टिकल ट्रांसलेशन क्या थी, वाई एक्सिस पे आपने क्या किया था, 3 यूनिट्स लेफ्ट चले गए थे, अब उसको रिवर्स करने के लिए 3 यूनिट्स राइट जाना पड़ेगा, तो यहाँ पे आप क्या करेंगे, +3 कर देंगे। एंड what does that give you? It gives you 8 minus 7, which is 1, 2 plus 3, which is 5. And that is the result that you get from this. 1 and 5, these should have been the coordinates of the original circle. Question number 2 from this paper. It says the diagram shows part of the curve with the equation y equals p into sine q times theta plus r, where p, q, and r are constants. We need to state the value of p first of all. That's what we are going to start from. What is p supposed to be? P is the number that is multiplying outside sine here. Now remember what it affects in a trigonometric graph. Sine के ग्राफ का जो amplitude होता है वो वैसे क्या होता है, 1 होता है, राइट? क्योंकि अगर आपके पास ये फंक्शन है y इक्वल साइन थीटा, इसके बाहर कोई नंबर नहीं है, तो इसका मतलब है 1 होता है। अगर 1 के अलावा कोई और नंबर आ जाए, फॉर एग्जाम्पल p here, that becomes the amplitude of the graph. Now remember what amplitude is. Amplitude is the maximum distance from the baseline of the graph. Baseline क्या होती है, जिसके अराउंड ग्राफ ऊपर नीचे जा रहा है। तो आप देखें बिल्कुल मिडिल में जो आपके पास लाइन आ रही है, हॉरिजॉन्टल लाइन, दैट्स दिस लाइन। अब इसके अराउंड आपका ग्राफ कितना ऊपर नीचे जा रहा है, आप देखें उससे आपको एम्पलीट्यूड मिल जाएगा। You see you have 3 units here maximum on the upper side, and you have 3 units going down on the lower side as well. The maximum distance from the baseline, how much is that? That's 3 units. So the amplitude of this graph that you have here is 3 units. तो जो p की वैल्यू यहाँ पे होनी चाहिए वो क्या होनी चाहिए, वो 3 होनी चाहिए। p should be equal to 3 here. Okay, now it says state the value of q. अब q क्या represent कर रहा होता है, देखिए अब अंदर q into theta, इसको आप दो तरह से समझ सकते हैं। You can either think of it as frequency, के जो नॉर्मल आपका इंटरवल है, जो नॉर्मल आपका पीरियड है ग्राफ का, उतने पीरियड के अंदर कितने साइकिल्स कंप्लीट हो रहे हैं। अब साइन का पीरियड कितना होता है ओरिजिनली, साइन का पीरियड ओरिजिनली कितना होता है, 2 पाई होता है। तो आप देखें 2 पाई इंटरवल के अंदर 0 से लेकर 2 पाई तक कितने साइकिल कंप्लीट हो रहे हैं। वेल 0 से लेकर 2 पाई तो आपका सिर्फ हाफ साइकिल कंप्लीट हो रहा है। ऑलराइट, तो इसका मतलब ये हुआ जो Q की वैल्यू होनी चाहिए वो आपकी हाफ होनी चाहिए। दैट्स वन वे ऑफ थिंकिंग अबाउट दिस। आप फ्रीक्वेंसी का सोच सकते हो। और another way of thinking about this is, remember जो भी आपके पास अंदर आ रहा होता है, अगर आपके पास ये Q है, इस ग्राफ का जो पीरियड है, न्यू पीरियड ऑफ द ग्राफ is actually equal to the original period of the graph divided by this number that you have here. All right, that's the relation between the new period of the graph and the original period of the graph. अब original period आपका साइन के ग्राफ का क्या होता है, साइन के ग्राफ का original period रेडियंस का कितना होता है, it's 2 pi. ओके, नीचे आपके पास क्यों है न्यू पीरियड, यानी ये जो ग्राफ आपके पास यहाँ पर आ रहा है इसका पीरियड कितना है, ये कितनी देर में अपना साइकिल कंप्लीट कर रहा है। ये ग्राफ अपना साइकिल कंप्लीट कर रहा है 0 से लेकर 4 पाई तक, तो इसका पीरियड कितना होगा, 4 पाई होगा। तो यहाँ पे 4 पाई लगते हैं, और यहाँ से भी आपके पास Q की वैल्यू उस तरह से आ सकती है, दैट्स 1/2। ओके, सो यू कैन डू इट आइदर वे। आप पीरियड का भी सोच सकते हो, आप फ्रीक्वेंसी का भी सोच सकते हो। पीरियड यहाँ पे क्योंकि डबल हो गया है तो वहां पे 1/2 आना चाहिए। ओके, आई होप दैट मेक्स सेंस। नाउ द नेक्स्ट पार्ट सेज, सो आपको सिर्फ स्टेट करना है, इसकी वर्किंग नहीं चाहिए आपको, सो यू जस्ट स्टेट 1/2 here and state 3 here, that's all that you have to do. Okay, Now the next part says state the value of R. Now, what about this number R? Remember, this represents the baseline of the graph. This represents the baseline of the graph. कि baseline आपकी कितनी ऊपर नीचे गई है. Originally जो साइन की baseline होती है वो क्या होती है? Y equal to 0. Originally जो baseline होती है Y equal to 0 होती है. अब ग्राफ पे देखें आप, आपकी baseline कहाँ चले गई है? ये येलो लाइन जो आपको नजर आ रही है, दिस इज द बेसलाइन ऑफ दिस ग्राफ, वो -2 पे चले गई है. तो आप क्या कहोगे? R की वैल्यू यहाँ पे क्या होनी चाहिए? -2 होनी चाहिए. Okay, so if you understand the transformations that you have for these sine and cos functions, this becomes pretty straightforward. जो बाहर नंबर मल्टीप्लाई हो रहा होता है वो एम्पलीट्यूड होता है, जो बाहर नंबर ऐड या सब्ट्रैक्ट हो रहा होता है वो बेसलाइन होती है, और फिर जो दरमियान वाला नंबर जो मल्टीप्लाई होता है अंदर ये वाला, that represents कि आपके कितने साइकिल्स कंप्लीट हो रहे हैं ओरिजिनल पीरियड के अंदर. फ्रीक्वेंसी की तरह सोच सकते हो, या फिर आप सोच सकते हो कि पीरियड पे जो भी इम्पैक्ट हो रहा है ना, ये नंबर उसका रेसिप्रोकल होएगा. सो पीरियड आपका डबल हो गया, यहाँ पे 4 पाई हो गया है. तो पीरियड डबल होने का मतलब है क्यू की वैल्यू क्या होनी चाहिए? 1/2 होनी चाहिए. So these are different ways of thinking about this. You can do it whichever way you're more comfortable with. Polynomials से move करें. It says express 2x² - 8x + 14 in this form. ये कौन सी फॉर्म है? ये कंप्लीटेड स्क्वायर फॉर्म है. Is it the standard form? स्टैंडर्ड फॉर्म नहीं है. स्टैंडर्ड फॉर्म में क्या होता है? a × x - h² + k. जो कांस्टेंट होता है ये बाहर होता है. यहाँ पे कांस्टेंट भी अंदर है, उसने ब्रैकेट ओपन नहीं किया बेसिकली. ठीक है. अच्छा, क्या करेंगे सबसे पहले? हाउ डू वी स्टार्ट? 2 कॉमन ले लें. अंदर आपके पास बचा x² - 4x + 7. 4 का हाफ करें, 2 का स्क्वायर ऐड भी कर दें, सब्ट्रैक्ट भी कर दें. This gives you a perfect square. These three terms, you have 2 × x - 2² - 4 + 7. And that leaves you with 2 × x - 2² + 3. And that's it. That's the form that we wanted. ठीक है. स्टैंडर्ड फॉर्म में क्या होता है? आप इसको सिंप्लीफाई करके लिखते हैं 2 × x - 2² + 6. ओके. लेकिन उसने इसी तरह की फॉर्म कहा हुआ है. यहाँ पे देखें, बाहर भी ब्रैकेट लगा हुआ है. You will just leave it like this. That's the form that you wanted. ये क्लियर है सबको? अब वो कहता है the functions f and g are defined by this. f of x is x² and g of x is 2x² - 8x + 14. एक फंक्शन f of x है, दूसरा g of x है. और g of x आप देखें वही है जो उसने फर्स्ट पार्ट में दिया हुआ था. ये एक्सप्रेशन describe fully a sequence of transformations. A sequence of transformation, that means it's going to be multiple transformations that maps the graph of y equals f of x onto the graph of y equals g of x, making clear the order in which the transformations are applied. Order का ध्यान रखना है. कौन सी ट्रांसफॉर्मेशंस हो रही है ये आपको लिखनी है यहाँ पे. f of x से g of x पे जाना है. How do we do this? कंप्लीटेड स्क्वायर फॉर्म यूज करेंगे. क्वाड्रेटिक फंक्शंस में हमने क्या कहा था? डायरेक्टली नहीं पता चलेगा आपको कौन सी ट्रांसफॉर्मेशन हो रही है. यू हैव टू कंप्लीट द स्क्वायर फर्स्ट. ओके. कंप्लीटेड स्क्वायर फॉर्म आपने यूज करनी है. अच्छा, अब इसका क्या मतलब है? ओरिजिनली आपके पास जो ग्राफ था दैट वाज x². ट्रांसफॉर्म्ड फंक्शन क्या है? g of x क्या है? जो ऊपर हमने फॉर्म निकाली है वो है 2 × x - 3² 2 × x - 2² + 3. This is the form that we have from the first part. ठीक है. अब क्या करें? कैसे डिस्क्राइब करें? कौन सी ट्रांसफॉर्मेशंस हो रही हैं? Before we do any of that, is this the standard form? अगर हम इसको स्टैंडर्ड फॉर्म में कन्वर्ट करें तो वो क्या होगी? रिमेंबर ऑर्डर जो हमने कहा था कि मल्टीप्लिकेशन और स्ट्रेच और रिफ्लेक्शन पहले होंगे, ट्रांसलेशन बाद में होगी वर्टिकल ट्रांसफॉर्मेशन में, और हॉरिजॉन्टल में ट्रांसलेशन पहले होगी, स्ट्रेच और रिफ्लेक्शन बाद में होंगे। वो स्टैंडर्ड फॉर्म के लिए थे। व्हाट वाज द स्टैंडर्ड फॉर्म? स्टैंडर्ड फॉर्म वाज लाइक दिस, एफ ऑफ एक्स के अंदर कुछ हो रहा हो और इस तरह से बाहर कुछ हो रहा हो। अब यहां पे एक नंबर इधर है जो इस पूरे के साथ ऐसे मल्टीप्लाई हो रहा है। दिस इज नॉट द स्टैंडर्ड फॉर्म। तो पहले तो आप इसको सिंप्लीफाई करके लिख लें। जो स्टैंडर्ड आपकी कंप्लीटेड स्क्वायर फॉर्म होती है, व्हाट वुड दैट लुक लाइक? 2 into x minus 2 whole squared plus 6। तो जो आपका ऑर्डर है वर्टिकल ट्रांसफॉर्मेशन का और हॉरिजॉन्टल ट्रांसफॉर्मेशन का, वो आप अब अप्लाई कर सकते हैं, पहले नहीं कर सकते। इज दैट ओके? अब क्या करें, कौन कौन सी ट्रांसफॉर्मेशन है? हॉरिजॉन्टल ट्रांसफॉर्मेशन कितनी है? इज ओनली वन, एक ट्रांसलेशन हुई है बस। और वर्टिकल कितनी है? वर्टिकल हमारे पास दो है। तो वर्टिकल और हॉरिजॉन्टल में से आप कोई भी पहले कर सकते हैं। आप वर्टिकल से स्टार्ट कर लें, हॉरिजॉन्टल से स्टार्ट कर लें, दैट डज नॉट मेक एनी डिफरेंस। ठीक है? अगर हम वर्टिकल से स्टार्ट करें तो वर्टिकल में कौन सी दो ट्रांसफॉर्मेशन है? स्ट्रेच एंड ट्रांसलेशन। इनमें से कौन सी पहले होनी चाहिए? स्ट्रेच पहले होनी चाहिए। वर्टिकल में स्ट्रेच पहले होती है, ट्रांसलेशन बाद में होती है। तो हम क्या लिखेंगे यहाँ पे? हम कह सकते हैं नंबर वन, यू हैव अ स्ट्रेच along y axis, या फिर वर्टिकल स्ट्रेच भी लिख सकते हैं, विद स्केल फैक्टर 2। दिस इज द फर्स्ट ट्रांसफॉर्मेशन। ठीक है? उसके बाद ये ट्रांसलेशन हो रही है, इसका आपको वेक्टर लिखना होता है। दिस इज ट्रांसलेशन विद वेक्टर 0 6, ये आपकी ट्रांसलेशन है। एंड देन नंबर 3, you can now do horizontal translation. What's the horizontal translation? 2 0 माइनस 2s का मतलब है 2 यूनिट राइट पे जा रहे हैं, दिस इज 2 0। अब क्योंकि ये दोनों ट्रांसलेशन इकट्ठी आ रही हैं, you could write them together like this as well, that it's a translation 2 6। क्योंकि ये एक वन आफ्टर द अदर आ रही है, इनको आप इकट्ठे लिख सकते हैं, दैट इज अलाउड। लेकिन अगर आप ऐसे करते कि ये वाली ट्रांसफॉर्मेशन उठा के ऊपर ले जाते हैं, हॉरिजॉन्टल पहले कर देते, अगर हॉरिजॉन्टल पहले कर देते और उसके बाद वर्टिकल करते, फिर इनको इकट्ठा नहीं लिख सकता था। बिकॉज फिर एक हॉरिजॉन्टल ट्रांसलेशन आपकी यहाँ पर आ रही होती ऊपर, वर्टिकल नीचे आ रही होती, उनके दरम्यान में स्ट्रेच होता, फिर हम उनको इकट्ठे नहीं लिख सकते थे। तो अगर ये वन आफ्टर द अदर आ रही हो इस तरह से, then you can combine them as a single vector. Okay, but if that confuses you, this is perfectly okay as well। आप इसी तरह से छोड़ दें, आपको वो करने की जरूरत नहीं है। ठीक है? That's not necessary कि आप उसको एक ट्रांसलेशन वेक्टर में लिखें, आप इस तरह में लिख सकते हैं। ये क्लियर है? तो स्टैंडर्ड जो आपका ऑर्डर है वो अप्लाई करने के लिए इट नीड्स टू बी द स्टैंडर्ड कंप्लीटेड स्क्वायर फॉर्म। ठीक हो गया? कोई मसला नहीं इसमें। Now another possibility could be कि आप इसी फॉर्म को यूज कर लेते हो जो उसने फॉर्म दी हुई है। आप ये भी कर सकते थे कि आप वही फॉर्म यूज कर लेते एज इट इज। अब ये कैसे करता? हॉरिजॉन्टल ट्रांसफॉर्मेशन तो अभी भी एक ही है, वो तो बहुत क्लियर है, हॉरिजॉन्टल तो एक है। वर्टिकल में आप देखें, ब्रैकेट्स लगा दिए उसने, अंदर +3 आ रहा है और बाहर क्या आ रहा है? 2 मल्टीप्लाई हो रहा है। अब जब ब्रैकेट्स लगा देते हैं और ये मल्टीप्लिकेशन हो रही है, ब्रैकेट्स का ऑर्डर पहले है मल्टीप्लिकेशन का पहले है? ब्रैकेट्स पहले आप इवेल्युएट करते हो। तो इसमें उसने एक तरह से फोर्स किया है कि ट्रांसलेशन पहले हो। अगर ब्रैकेट्स आप लगा दो, इसका मतलब है कि ये जो +3 है ये पहले होएगा और फिर मल्टीप्लिकेशन उसके बाद में होगी। तो अगर आप इसी को यूज करते, another possibility could be that you write this as a translation of 0 3 vertical translation, and then number 2 you could say it's a stretch along y-axis, vertical stretch with scale factor 2, and then finally you could write a translation of 2 0. This could be another way to write that same transformation. अगर आप ये ट्रांसलेशन और स्ट्रेच का ऑर्डर उल्टा कर दें, तो देखें पहले ट्रांसलेशन आपको 0 6 करनी पड़ रही थी, अगर ट्रांसलेशन पहले करते स्ट्रेच बाद में करते तो ट्रांसलेशन 0 3 हो जाती। ये भी आपको सेम रिजल्ट देगा। अगर आप उसको ग्राफिकली देखें, आप डेस्मॉस पे ट्राई कर सकते हैं, अगर आप करना चाहें कि इन ट्रांसफॉर्मेशन से ये फंक्शन कैसे चेंज हो रहा होगा। नहीं, मेरे नहीं आया, ये नहीं है। दिखाएं सर, नहीं ये किसी और की है, ये मेरे हैं। ठीक है, इसमें कोई मसला नहीं है तेरे सबको। इन दोनों तरह से हम ये कर सकते थे।